to Mr. Ring's website or to his YouTube channel. He will teach you to learn to love math again. Mr. Ring, the #1 math teacher in the whole world.
We're going to be using the factor theorem in this section for the next couple of days. And before we do that, it tells us A, determine each function value. So #1, determine P of 3. Everyone say that. It's kind of saying putting 3 into the function of P. And then they're actually telling you the function, right? One of my kids gave me a toy yesterday and said the toy's broken, right? And it's this little camera, and you put in slides into the camera. And they had put in the slides in the wrong direction. Or another way of thinking about it is we're going to put a 3 into this function. Look at this calculator. It has a cover. You're putting the cover on to the calculator, right? You're going to put 3 into the function. Another way of clearly seeing this is this part right here. These two are the clues. If you put P of X right above it, do it. Repeat after me. Same. P is the same, right? X is what? Same or different? Different. So look, this is where I'm using my highlighter. X is equal to what number, class? 3. We're going to put in 3 for every time I see X. Let's substitute in 3 for every time I see X. Now, it's possible in this problem that you make lots of mistakes, but the first thing we're going to do here is just the substitution. Substitution. The next thing we're going to do is we're going to simplify. Now, when I simplify, there is an acronym in math that we use. Partner A, tell partner B about your aunt. Not your uncle, your aunt. Angie, do you know something about your aunt? Maybe your aunt farted or something like that? Everyone talk to your partner in 5 seconds. Is that good? No, I don't think so. Yes, Angie. Inappropriate fart in the middle of dinner. Please excuse my dear Aunt Sally. This helps us simplify, okay? Now, I'm also, as I do these, I'm going to go left to right. So here is a parentheses, but there's nothing inside the parentheses, so I'm going to do the exponent first. So this would be 2 times. The temptation for the students is to do 2 times 3, and then they do 6 to the 3rd power. That would be incorrect. So here I'm doing 3 to the 3rd power, that would be 27. 3 squared, class? 3 times negative 36. Feel free to use your calculator. Alright, what was negative 36 times 3? Huh? Positive or negative? Okay, now I'm going to do multiplication, division, left, right as I see them. So this is multiplication. Now, if you multiply those two, what do you get? Please use a calculator. Here. Negative 54, negative 108, minus 36. This is a positive, this is a negative, so that's 0. And negative 108 minus 36. Negative 144. me box that as our answer. I'm going to show you guys a visual of what this means, and then we'll actually use calculators. Okay, what does this mean? It's basically saying if you have a graph and it's a cubic function, I don't know, something like this, right? It's saying when your x value is 3, where does it touch the graph? So essentially what you're doing is you're going right 3, and then our answer is negative 44. So essentially what the answer is that blue point, 3, comma, negative 144. Okay, let me show you guys some technology. If I give you a problem like this, of course I want you to show me step by step. Prove to me that you're not copying off your friend's paper. Okay, so I'm using this calculator. Scientific calculator. Let me see if I can put that a little bit easier to see. That help. This help. Okay, that looks better, right? Okay, so if you have this calculator, I'm going to go to mode. So just press mode. And I'm not an expert on Casios, but I think this would work on generally the scientific ones that have a nicer screen like this. And I'm going to go down to table. So press 3. And then I'm going to plug in my polynomial. This one. 2x. X is in red over here. You see it? So I'm going to press alpha, close parentheses, to the third power. And to get rid of the exponent, you just go towards the right. Let me show you the next one. So minus, press the minus button, 6. Okay, this is how you get a variable. Again, it's in red. Next to next to the end parentheses, or the delete button. Okay, so I have to press alpha, close parentheses, and it has a power of 2, so you can press either this button or the power button. Press the power button. And then you go out, so we'll go to the right, minus 36, and variable button, you're going to press alpha, close parentheses, and then minus 36. And if you press enter, or equals, you're going to get a second function. Just skip it, so press equals. And it's going to say start at 1, sure. End at 5, sure. What you want to do is make sure it includes x equals 3. But the number we just did, x equals 3, press enter equals, and you went to step 1, press equals. Ooh, everyone say yay. The calculator found the answer. So if you know how to use the calculator commands, guess what? You can check your answer with the calculator. Or one of these calculators, which I still have 30 to check out. Especially if you're a junior and you're begging Mr. and teach me free calculus, you will use this calculator. 2x to the third minus 6x squared minus 36x minus 36. If I go to my table and I scroll down to 3, I'm going to get an answer of negative 144. Negative 144. So although you're doing this by hand, you can easily make a mistake. You can check your calculator.
I love man. You don't love man? What's wrong with you? I love man.
Partner A, tell partner B, what is your x value? What is your x value? Angela, what's your x value? -2. Every x value we're putting -2. Now this problem is so large, it kind of went on to the second line, so I'm going to rewrite it out, the original. And let's go ahead and put in x equals -2. Thanks, Angela. Mariana, tell me what to write. Thank you. Darian, -2 to the 4th power. Darian, should you do -10 times -2 or -2 to the 2nd power? Say it again, is that what you said? Please consult your aunt. This is the #1 mistake in simplifying, trust me. Everyone talk to your partner in 5 seconds. Darren, should I multiply or do exponents first? Exponents. Order of operations says exponents. So, Darren, what is -2 to the 3rd power? It's amazing, this thing tells you, huh? Yeah. Here is a mistake you can put into your calculator. The mistake would be this: -2 to the 3rd power. This one will read -8. Let me explain why this one is wrong. The calculator is not wrong. The person inputting is incorrect. The -2 is inside parentheses. So you have to put yours inside parentheses. Now, because it's to the 3rd power, it'll still become negative. But do pay attention to the parentheses signs. And Darian, -8 times -10. Positive 80. Selena, should I multiply or do exponents? -2 squared. And 4 times 8. 30 what? 4 times 8? 32. Megan, -2 times 106. Positive or negative? So we can just put all the positive numbers together. Melissa, you're in charge of all these. And Brian, you're in charge of all the negatives. I mean, you could just add those and just subtract. Melissa, what do you get here? Brian?
317.
And if you subtract those, class, what do you get? Negative. $100. Negative 189? Sounds right. Alright, draw yourself a picture. See if you can draw the sketch. Kind of visualize what we're doing. Tell your partner one thing you know about the graph. Ready, set, go. Chris, what's one thing you know about the graph? Where are the arrows? How did you know that? Yeah. The highest exponent or degrees of 4, that's an even. So starts up, ends up. If I look at where x is equal to negative 2, my picture is not really correct. Because then we're basically saying the graph should have been something like way down here, right? Negative 189. Something like that, maybe. Negative 2, comma, negative 189. We're going to be using the factor theorem, and we're going to first determine each function value. In question number 3, it says, determine p of negative 3 if p of x equals 2x to the 4th plus 5x third plus 8x squared plus 15x plus 6. The key to this problem is right here. I notice they both have a p and a set of parentheses. So what I'm going to do is going to write p of x above it. And this is going to tell me something. P's are the same, the parentheses are the same, but x and negative 3 are different. So that means your x is equal to what value class? Negative 3. So now what I'm going to do is I'm going to put in an x value of negative 3 every time I see x. Now, in this computer-generated problem, they kind of went to the next line. So what I'm going to do is I'm going to write the original problem, write small, so it fits in one line. And basically every x value is going to be what? Negative 3. So every x value now I'm putting in as negative 3. Notice how as I'm doing the substitution there in yellow, I'm using a parentheses. Hopefully you didn't make that mistake last year where you just put in the number. And now I'm going to simplify. Tell your partner of an acronym that can help us learn to simplify. Ready, set, go. It might involve your aunt, not your uncle. Class, on the count of 3, we're going to say a phrase. Ready? 1, 2, 3. And this tells us how to simplify. Now, class, this is the number one mistake in simplifying a problem like this. Okay? Class, should we do 2 minus 3? It does not read 2 minus 3. It says 2 times negative 3. Class, should I do 2 times negative 3? No. The number one mistake for students is to think to multiply. Is multiplying first in our list? No. It tells us to do parentheses and exponents first. So I'm going to do negative 3 to the 4th power first. Let's do that. Now, I went to practice showing you how to use a calculator. And another mistake that students will make is they'll put in negative 3. Let me show you my calculator. Negative 3 to the 4th power. So my negative sign on this Casio is up here. If you have a Texas Instruments, it's usually at the bottom of the calculator. And the exponent button is here. Let's see if I can. Now, this is wrong because it doesn't actually have a set of parentheses. Your calculator is actually reading it as positive 3 to the 4th power, and at the very end, then take the opposite of that number. To get negative 3 to the 4th power, you're going to make sure that you have a set of parentheses. And this will give you a positive 81. Class, negative 3 to the 3rd power? Class, negative 3 squared? And I have no exponent, so I can just multiply here. 15 times negative 3. Use your calculator. 2 times 81. 5 times negative 5 times negative 27. Now, be careful here. You're not subtracting. Remember, when you have no math operation there, it's multiplication. 8 times 9. And a nice thing, if you have a calculator that has a bigger screen, you can actually input all of that at once. So 162 minus 135 plus 72 minus 45 plus 6. And I got 60. See if that's reasonable. Looks reasonable. So my answer is going to be P of negative 3 equals 60. Raise your hand if you got that. Now, I don't want to lose sight of what this is, so let's draw a picture. Let's draw a polynomial. Put your finger on the highest degree. Class, is that an even or odd? Even. Okay, so let's draw a sketch. Starts up, ends up. I'm going to have one last turning points. So if that's 4, degree minus 1 tells us I'm going to have 3 extremas there. And we used x equals negative 3. So if I put my pen a vertical line at negative 3, put your finger on the intersection. This intersection is the order pair negative 360? So basically what we're asking is, on this graph, what is the x value at x equals negative 3? The answer is 60. So this visual kind of tells us what we're doing with all the algebraic. So even though you do have a calculator, I do want you guys to show all your work. Remember, the key to the problem is the very beginning. Put that right above and you'll determine x equals negative 3. So my graph, maybe move it over, I don't know. Because they were saying that's positive 60, my fault. I don't know. Maybe the bump's over here. Let's see that. So, right there, not there. Can I? The graph?
Yeah, do it from negative 60 to 60. Would it move over or would it just move the graph up?
Yeah, but the y value is just positive, right? We're going to be using the factor theorem, but to do that, I haven't explained what the factoring theorem is, but we just need to determine each function value. So let's do number 5. Super handy today if you have your calculator. Determine p of 10 if p of x equals 6x to the third plus 11x squared minus 3x minus 2. Alright, I'm going to use my pink pen and tell you that right here, underline it, this is going to be your, you can't see, this is going to be your key to the problem. Focus, 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 there you are. Okay, underline that. That's going to be your key to the problem. So what I'm going to do is I'm going to write this one right above it. P is the same, the parentheses are the same, what's inside the parentheses is different. Cos x is equal to what number? 10. This tells you the key. This tells you what to substitute. That means for every x value, we're going to put in what number cost. Let's do that together. So I have p of 10 equals 6 times 10 to the third power plus 11 times 10 squared minus 3 times 10 minus 2. Okay, all I did there was just a substitution. Let's write that on the side. What did I do? Number 1, substitute. The second thing I'm going to do is simplify. Here's a question to talk with your partner. Should you multiply or do the exponents first? And what tells you what to do first? Talk to each other. Ready, set, go. Raise your hand if we should multiply first. Raise your hand exponents. Partner B, tell partner A what your aunt would tell you. Not your uncle, your aunt. What would you do if your aunt farted during a nice dinner at the family gathering? What would you tell your aunt? Class, what's the answer? Please excuse my dear Aunt Sally. Alright, because if Aunt Sally was there, we would say, excuse you. What does that tell us? The number one mistake in doing this problem is students will say 6 times 10 is 60. Class, why is that wrong? You have to do exponents first. Someone's going to fall into the trap. Don't let it be you. 10 to the third power is what we need to do first. So, If you don't know, you can use your calculator. So pull out your calculators. Now I have this Casio, and to do this, I'm going to press on. Let's see if I can. And I'm going to have to press 10 to the third power. So I'm going to press 10. And then the button I'm going to press is the exponent button. Some of your calculators have like x to the y power. And then I can just type it through there. And press enter. And I get 1,000. Okay, so we just got 10 to the third power equals 1,000. Put that there. Class 10 squared is 100. Now I don't have any exponents, so I can just do multiplication. Negative 3 times 10 minus 2. And then we just go back and simplify. 6 times 1,000. 11 times 100. 1,100 minus 30 minus 2. And the nice thing is you could actually just put that into your calculator. Let's do that. 6,000. Delete that. Delete. Plus 1,100 minus 30 minus 2. And I got 7,068. Is that what you guys got? And then you can just bring down this P of 10 down. And I just need to show you guys two more things. I'm going to show you a graph, and then I'm going to show you guys calculators. Graph and then calculators. Okay. Put your finger on the degree of the polynomial. Which one is the highest degree? Show your partner. Tell your partner what do you know about these degree polynomials. What does it look like if you graphed it? Where are the arrows? Class, where are the arrows? Starts down, ends up. Let's draw that. Starts down, ends up. And I'm going to draw, where I have x equals 10, a line. Where x equals 10, my highlighter that I substituted in, I'm going to draw on the x-axis at 10. So let's draw a sketch. There is an odd degree polynomial. A value, the number in front, is positive, so we're going to keep it. And purple box, purple point. Purple box, purple point. What does that mean? This means that the order pair is 10, 7,068. If I put in my graph at 10, it will intersect at 7,068. Okay? So this is a visual of what we've been doing. Now let's show you the technology. Okay? Alright, so if you have this Casio scientific calculator, I'm going to show you guys how to use it. So you press on, and if you press mode, some student showed me hers, she had 7 options, but I'm just going to press table. And what I'm going to do is I'm going to type in this really big function that we talked about. So to get to the calculator commands, that'll be 6 x. X is above the delete button in red, so if that's in red, I have to press red first. So that'll be alpha close parentheses. And then to get to the power of 3, I'm going to have to type in the exponent. Now to get out of the exponent, you have to press right. So plus 11x squared. Again, the X button is in red, so I press alpha, end parentheses, squared, minus 3x minus 2. So put all that into your calculator. I'm going to press equals. G of x is a second function. I'm going to just press equals. It's telling me where do I want to start. Okay? I want to make sure my start and my end includes 10 in there. So start at 1. It says end at 5. No, I want to end at 15 because 10 is between 1 and 15. Steps, that's how I want the x values to move up by. So I'm just going to press equals. Okay, so at 10, we're saying that the answer was 7,068. And there it is. What does this mean? Your calculator can actually calculate the answer for you, and you can just check your answer by using the calculator. Is that pretty nice? So if you get this big number and you're not sure if it works, then you can use your calculator. Let me show you really quickly with this calculator. I'll go a little faster on this one. 6x to the third plus 11x squared minus 3x minus 2, second table. If I go to 10, $7,068. Let's give you a visual. There's my visual. I change it up a little bit. 10 would be something way over here, right? So the graph's like way up there. So at least that gives you a visual of what's happening. Let's take a look. Alright, here's our math. They put in... Oh, you guys see what happened?
Oh no.
All you had to do is just substitute in what? Positive or negative 1?
Positive.
I think the student, remember, if you want to ever go between here and there, this is x equals 1, so if you subtract 1 from both sides, you get x minus 1 equals 0. So I'm going to put this box as the big idea. X minus 1 is the same thing as x equals 1. Same. Now, I like that the student had the sentence. When p of x is divided by negative 1, the remainder is some number. So let's double check other students' work. So I have 1 to the 4th power, correct. This is 1 to the 3rd power times, that is 1, correct. 1, 1. And then I get 3 times 1 is 3, yes. Negative 6 times 1 is negative 6, yes. And then 1 plus 3 is 4. 4 minus 6 is negative 2. Negative 2 minus 8 is negative 10. Good. So, like the student recognized me, just missing the work there. Now let's check the last one here. And we get the same thing, right? Raise your hand if you got negative 10. Good. Determine each function value. We learned on Friday that if you put p of x right above this, you'll see that your x value is going to be 1/3. Now, I'm going to write this problem out again because it got kind of cut off into the next line. And I was encouraging you to use fractions minus 9x minus 18. And every x value we're going to put in as 1/3. So p of 1/3 equals 1/3 to the 4th power minus 1/3 to the 3rd power plus 7 times 1/3 to the 2nd power minus 9 times 1 to the 3rd power minus 18. And really what this means is 1 to the 4th power, so that's 1 times 1 times 1, which is just 1. And this one's going to be 3 to the 4th power, which is 81. Or you can think of it as 1/3 times 1/3 times 1/3 times 1/3. Same thing over here. This tells you that this is going to be 1 to the 3rd power, so 1 times 1 times 1, which is 1. Class 3 to the 3rd power is 27. So I have minus 1 over 27. Remember, we learned on Friday's lesson to do exponents first before you multiply. So 1/3 times 1/3, this will become, or 1 squared is 1, 3 squared is 9. Okay, now when you get to a whole number times a fraction, class, how do you make negative 9 a fraction? I'm going to put it over 1. And that can help you show negative 9 times 1 is negative 9. And that's over 1 times 3, which is 3. And then the negative 18 stays the same. Alright, so I'm just going to go over and simplify these. So 7 times, remember we're going to make that a fraction by putting it over 1. 7 times 1 is 7. This is positive. And 1 times 9 is 9. Class, what's 9 divided by 3? Negative 3 minus 18. And this one doesn't look like to be a fun fraction to. You could get a fraction, but you're eventually going to get a decimal anyways. So let's go ahead and convert those. So what I'm going to put in my fraction is 1 divided by 81. Some of your calculators can actually put all of this in at once. So let me try that with this calculator. But I will show you what I'm putting in here. 1 divided by 81. And if you get a fraction like I did on my screen, your calculator might have a button called S to D. I think it's standard to decimal. So if you press it, it will give you a decimal. Or if you go back, it should give you a fraction. See that? Now, let's try with this calculator. Let's see if I can put all this at once. I'm going to use parentheses. 1 divided by 81 minus parentheses 1 divided by 27. Close the parentheses. Plus 7/9 plus parentheses 7 divided by 9. Again, not all calculators can do this, so you might have to individually do them and then add and subtract. Minus 3 minus 18. And it gets a big fraction for us, and then I can just convert it to decimals. So my answer is going to be, really 1/3 is 0.33, and that equals negative 20.24. I'll just stay there. And then on Friday, we learned to make a sketch. So this is a 4th degree polynomial. Even degree, starts up, ends up like a quadratic. Leading coefficient A value is 1, so it's going to stay that way. So it starts up, ends up. And remember, 4th degrees look like, most of them look like W's. And on Friday's lesson, we learned to highlight 1/3. The point of this 1/3 here is to help us focus there on the graph. And at 0.33, so like 33 cents, a little bit less than $1, but more than 0, on the positive side, it's down, going negative. So this represents the order pair, 0.33, comma, negative 20.24. That's what this function notation represents. It's an order pair, and there it is on our graph. Today's lesson, we're going to see if this is actually going to hit exactly on the x-axis. So that pink line is just to help you focus where is the graph intersect at 0.33.
I love the Smiths. I said I love the Smiths. You practice music.